All right, so we're going to touch on naming compounds today. This video may be a little longer than our others, but I'll try to make it as swift as possible because there's a lot of information you're going to want to pause this video and write down for your naming of compounds. If this is your first go at naming covalent and ionic compounds, you will be doing quite a bit of pausing. For those of you who are proficient or have seen this before, please feel free to fast forward through to any other portions you may be needing. All right, so first we're going to talk about some of the main topics or concepts necessary for naming compounds. So one of the things we're going to make mention of a little later in the video is going to be the crisscross or the lasso method. Okay, so please make sure that you listen out or look out for that crisscross or lasso method when naming compounds. Okay, so the first thing we want to do is determine each element's makeup. Okay, so when we look at our compounds, we're going to have different elements making up those compounds. They could be metals, nonmetals, or they could be polyatomic ions. And those you'll see quite often living in what they call houses in your compounds or parentheses. Okay, so you'll see a number of compounds that'll have parentheses and a subscript or a small number written on the lower right corner. So those are going to be your polyatomic ions. And this step of determining each element, whether it be a metal or a nonmetal, will help you to determine if the compound is ionic or covalent. Ionic compounds are metals and nonmetals. And then covalents are going to be non-metal and non-metal, or two non-metals in a compound. And you'll see there's a small item here, and we will reference that at the bottom of this note, okay? So when we're naming our compounds, we're going to name the first element without changing the ending. Okay, and when we do these items or name these compounds, this will become a little more apparent to you then, okay? And then our second element, the changing of the ending comes about to where you are then going to go from what you're accustomed to seeing as an INE in most cases will then change to IDE. So chlorine, as it appears on the periodic table, changes, which is what this triangle or delta sign means. It's going to now be chloride. And if you remember, we had this little asterisk here. Let's think about this note here. In covalent compounds, prefixes are used to notate the number of each element in a compound. So please beware that the prefix is used for covalent compounds. So covalent compounds are going to be our two non-metals, okay? And in the beginning, you will hear me as videos go on. I will reference those as coefficients to remember that covalent compounds get prefixes. And if we remember, coefficients come before a variable, okay? And that terminology will change as the videos progress because we will be getting to using terms such as moles to represent the number of a certain element, okay? All right, so now we're going to take a look at our ionic compounds. Ionic compounds, okay? So we have our ionic compounds here. So let's see what we're dealing with here. Ionic compounds are nonmetals and metals that are combining. And if you think about it, ionic compounds are ironic because we are combining two unlike things. So here we're going to go from formula to chemical name. So if we look at our periodic table, we're able to see that sodium is a metal and chlorine is a nonmetal. So in doing this, we were able to determine that the compound is ionic. And if we listen to the rules from before, the first compound or the first element in the compound is sodium. The second element is chlorine. But we know, according to the rules of naming, the first element stays the same, and we change the ending of our second compound from INE to IDE. So NaCl, from chemical formula to chemical name, and the chemical name is sodium chloride. Okay? Our next example, we're going to go from chemical name to formula. So I will tell you that the use of a common anion, cation, and polyatomic sheet will be very helpful because you'll need to know the charges of your different elements in your compounds. So here we're going to go from chemical name to formula. So here we have aluminum oxide. We know that aluminum is a metal, and oxygen or oxide is going to be a non-metal. Okay? According to either your text or your resources you've been supplied, you would be able to determine that aluminum has a 3+ charge and oxygen has a 2- charge. So this is when our crisscross or our lasso method comes into effect. So I'm going to move the screen down, and I want you to pause so that you have a moment to write these different items down. So here, in order to get my charges, I used an ion charge page, whether it was in the textbook or in the resources provided by my professor. I would then use the crisscross or lasso method to change the superscript for the charge. We're going to drop the symbol, and it is going to then be in the subscript position. So whatever was attached to my second element in the compound will now be the subscript for my first element. And then the charge for my first element will now be the subscript for my second. So for aluminum oxide, I have Al2O3. And it tells you here if each element has the same charge, no subscript is needed. So if both of these had been a 2, it would not have been necessary for us to place that there. Okay? So we have done ionic compounds. So please, if necessary, take a moment here and pause. All right, welcome back. We are now going to take a look at polyatomic ions in naming. Okay, so once again, we're going to be using the rules of ionic naming, and you're going to want your polyatomic or ion sheets in order to do these problems. Okay, so here once again, we're dealing with polyatomic. So if looking at a chemical equation and it consists of the parentheses or the house or more than 2 elements after your first one, you know you're looking at a polyatomic. Okay? So potassium in our first example we know is a metal. And then we look at promanganate. We know if we look at our periodic table and we search and we search and we search, there is nothing that is remotely like that name. But also if we look at the ending, ATE or ITE at the end of a word would let us know we're also dealing with a polyatomic ion. Once again, we're going to be doing the crisscross method with our charges. So we know potassium has a +1 charge, permanganate has a -1 charge, and as stated before, if those subscripts are the same number, there is no need to write them. So we would take our potassium and we would put it with MnO4, which is the chemical formula for permanganate. All right. Another example of going from a chemical formula back to the actual name. If we take a look at our polyatomic sheet, we know that Ba is barium and NO3. But here we see that 2 on the outside. That lets us know that barium had a 2+ charge that was utilized during that crisscross method. So we know by looking for NO3 on our polyatomic resources, it is going to be nitrate. Okay, so we have barium nitrate. And if we were to take that and want to do it in the opposite, taking it from name to formula, we know that barium is Ba2+, and nitrate is NO3 -1. We do our crisscross method as before, but remember to place our polyatomic ion in the house, because if we look at the little note here, without the parentheses or without the house, it would appear that you had 32 oxygen atoms and not just the 3. Okay? So I'll bring that in a little closer. So stating without the parentheses, it would appear to have 32 oxygen atoms. So we want to make sure that we place those parentheses around those polyatomic compounds. All right, so now the last one is going to be our covalent compounds. And here you see at the very beginning of this post-it note, it discusses prefixes for chemical nomenclature. Prefixes for chemical nomenclature. These are going to be the prefixes used for covalent compounds. Okay, so please make note of these. These are not the same ones used for organic chemistry, for the naming of organic structures. These are the prefixes for the chemical nomenclature of naming compounds. So here we see in our light bulb moment, prefixes represent the number of atoms each element has in a compound. Prefixes are used only in covalent compounds. And a side note is if the first element has only one atom, mono can be omitted. And also think of prefixes as a coefficient before the element's name. So covalent, it's coefficients. And in this sense, we're thinking of coefficients as prefixes, okay? Prefixes. So our 10 prefixes are as follows. 1 is mono, 2 is di, 3 is tri, 4 is tetra, 5 is penta, 6 is hexa, 7 is hepta, 8 is octa, 9 is nona, and 10 is deca. Okay? So here, just like in the first example, we're going to do one here. We're going to go through and determine in our first step which type of element we have. So we have sulfur and we have fluorine. Okay, we know sulfur is a nonmetal. Fluorine is also a nonmetal. So here we have determined we have a covalent compound. So we're dealing with SF6. So we know we have sulfur and fluorine, but the rules of naming let me know I need to change the ending of my second compound. So instead of fluorine, I will now have fluoride, and sulfur remains the same because if it only has one, we can omit the prefix mono for that first element, okay? So here we have 6 fluorines. So looking at our list, 6 goes with the prefix hexa. So here we're going to have sulfur hexafluoride. Sulfur hexafluoride. So please make sure you go back, take a moment to jot down those light bulb moments and all of the items that have anything that has to do with the rules of naming these compounds, because as you go further into your chemistry course, you will see this again in some of your balancing equation problems and making sure that your compounds are in the proper order, meaning which comes first, the cation or the anion. And you want to make sure also that you have the proper charges. So remember, our cations come first, and then our anions come second. So think positive before negative. Always give a compliment before you give a criticism. Okay, so positive before negative. So once again, as always, happy studying, and I wish you much luck and success.